Hello and welcome to my Calculus 3 or Multivariable Calculus problem solving series. In this video, we're going to look at how to find the velocity and acceleration of an object whose position is a curve in 3D. So this question asks us to find the velocity and acceleration of r of t at t equals 5 and 10, where r of t is a vector valued function, which is 5t comma t squared comma 2t cubed, and it gives us this curve in space. So because it's a vector valued function, it has the parameter t, and it gives us this curve. Now you could also think of this as t being time, and that you're an object on the curve, or you're walking along the curve and you're moving along this curve as the time increases. So when t equals 5, you're at one place, and then you move, and when t equals 10, you move to a different location. So how do we find the velocity and acceleration of r? Well, so if r is the position, then the velocity, the definition for velocity, is how much the position is changing over time. So that would be like the slope of r of t. So to get the velocity, we're going to take the derivative of r. And acceleration, the definition for acceleration is how much the velocity is changing over time. So if you're speeding up or slowing down, then your acceleration is changing. So to get the acceleration, we're going to take the second derivative of r, or take the first derivative of the velocity. And we can see that here. So if r is 5t comma t squared comma 2t cubed, then v, the velocity, is going to be r prime, which is 5 comma 2t comma 6t squared. And the acceleration is going to be the velocity, the derivative of the velocity, or the second derivative of r, which is 0 comma 2 comma 12t. And when we plug in the numbers, so when we plug in t equals 10, we get that the velocity equals 5 comma 2t, or 2 times 10, 20, and 6t squared, t squared, or 10 squared is 100, so 6 times 100, 600. And the acceleration is going to be 0 comma 2 comma 12 times 10, which is 120. And when we plug in 5, so when t is 5, the velocity is going to be 5 comma 10 comma 150, and the acceleration is going to be 0 comma 2 comma 60. So as you can see, this curve, when you go from t equals 5 to t equals 10, you speed up a lot, especially in the z axis, and your acceleration also increases. So that's going to be all for this video. Thanks for watching.